Welcome, everyone. It is a pleasure to have you here today as we explore YTP, the Terminal User Interface Renaissance. This session provides an in-depth architectural analysis of modern Rust tooling, the evolving capabilities of TUI multimedia, and the integration of edge artificial intelligence. As we examine the technical schematic before us, we will engage in a detailed case study and architectural deconstruction. Our goal is to understand how these converging technologies are reshaping the landscape of developer tools and redefining our interaction with the command line. Let us begin our deep dive into the evolution of the terminal experience.
Redefining the CLI utility, YIP is a terminal-based U2 player that bridges the gap between lightweight command line tools and feature-rich graphical interfaces. It achieves high-fidelity video rendering and local AI processing, capabilities traditionally reserved for heavy GUI applications. At its core, YIP handles audio and video playback through MPV bindings, while differentiating itself with visual thumbnails and live AI-powered transcription. Built entirely on a 100% Rust stack, the YIP binary serves as the central hub, connecting high-quality video rendering, precise audio playback via MPV, and advanced AI transcription services into a single, efficient terminal environment. Today, we're exploring 3 structural breakthroughs that mark a significant departure from conventional CLI design patterns. These shifts are transforming the terminal from a basic text input field into a highly sophisticated environment for modern development. The first breakthrough is visual fidelity. We are actively breaking the text-only barrier by introducing rich visual elements and high-fidelity graphics into the terminal space. This allows for better data visualization and a more intuitive user experience without leaving the command line. Next, we have local intelligence. This focus on privacy-first embedded AI means that smart features and predictive logic are processed directly on the user's machine. This approach prioritizes data security and reduces latency, bringing advanced computational power to the local environment. The third pillar is what we call the luxury CLI. This refers to the integration of state persistence and premium aesthetics. By maintaining context across sessions and applying high-level design principles to the interface, we are creating a terminal experience that is both functionally superior and visually beautiful. These 3 elements together define the next generation of interface design. Our first key insight focuses on breaking the text barrier within command line interfaces. For decades, conventional wisdom has dictated that terminals are strictly for text grids, where any visual representation was limited to ASCII art and basic characters constrained by a fixed cell structure. However, we are now seeing a fundamental paradigm shift. By utilizing modern technologies like the Sixel and Kitty protocols, we can treat the terminal as a dynamic canvas rather than just a text display. This shift allows YIP to leverage the capabilities of modern terminal emulators to render high-fidelity graphics directly. In doing so, we are challenging the long-standing notion that CLIs must be purely log-based, enabling a much richer and more intuitive user experience without ever needing to leave the terminal environment. To implement adaptive rendering, we utilize a protocol negotiation logic that evaluates the specific capabilities of the terminal environment. Starting with the raw image data, which can encompass various frame modes such as static thumbnails, storyboards, or live video, the system dynamically determines the optimal rendering path. For modern terminal emulators like Ghosty or Westterm, we utilize high-fidelity protocols such as Kitty or Sixel to provide true image quality. If these protocols are unavailable, the system steps down to medium fidelity, employing half-block characters with direct color to approximate the visual data. Finally, as a universal fallback, we provide a low-fidelity ASCII representation, ensuring that content remains accessible and functional across all possible terminal environments. Our second insight focuses on AI at the edge. Conventional wisdom suggests that AI requires heavy Python environments and constant cloud connectivity. However, we are moving beyond that paradigm. By eliminating the need for API keys and removing cloud latency, we ensure zero-latency offline capability. Our platform integrates speech-to-text through native bindings using a local runtime built on Rust and C++. This approach allows for high-performance execution directly on the device, bypassing the limitations and dependencies of traditional cloud-based AI deployments. The implementation of the Whisper-CLI-RS bridge facilitates a seamless transition from raw audio to structured text. As shown in the diagram, the incoming audio stream is processed through a real-time synchronization layer, which segments the audio and generates text in sequential blocks. This allows for immediate outputs, such as "Hello World" or real-time transcription as the speech occurs. Technically, the system is built upon the Whisper-Cly RS library by Miguel Piedrafita, utilizing Whisper.cpp bindings as its core engine. We employ the ggml small.bin model, a 460 megabyte file that the system can automatically fetch. By executing as a native binary, the bridge achieves maximum performance and minimal latency, ensuring that transcription remains perfectly in sync with the live audio.
Insight 3 introduces the concept of the luxury TUI, representing a fundamental shift in our design philosophy. We are moving away from the utilitarian austerity typically associated with terminal tools and toward a focus on consumer-grade retention. Our core concept prioritizes joy of use by implementing state persistence, smooth navigation, and aesthetic personalization. While traditional CLIs are often stateless and rigid, YIP is specifically designed to feel like a high-end application, bridging the gap between functional power and a refined user experience.
Moving on to the implementation of state and aesthetics, we have integrated a robust theming engine that features 12 baked-in visual styles. Users can seamlessly cycle through these options using the Ctrl+T keyboard shortcut. To maintain consistency, we prioritized persistence, ensuring that user preferences survive between sessions. This is managed via a configuration file, such as the prefs.toml file shown here, which stores settings like the active theme, frame mode, and volume levels. This functionality is fully supported across macOS and Linux platforms. Additionally, we implemented an infinite scroll pagination logic for navigation, which facilitates a fluid and uninterrupted experience for channel browsing. This slide illustrates the Rust ecosystem stack, organized into 3 distinct layers that represent the architecture of a typical robust application. At the top, we have the interface layer. This is responsible for the user-facing aspects of the software, specifically focusing on TUI rendering and the underlying theme engine that defines the visual aesthetic. Moving down, the logic layer serves as the central processing hub. It manages the asynchronous runtime, handles complex search filtering operations, and maintains the overall state of the application through a dedicated state manager. Finally, at the base, we find the core and I/O layer. This foundational level interacts directly with system resources and external services. Key components here include MPV for media playback, Whisper for AI-driven inference tasks, and Request for handling network communications. Together, these layers demonstrate how Rust's diverse ecosystem can be leveraged to build complex, well-structured, and efficient applications. Our navigation system utilizes Vim-style filtering and key mappings to ensure maximum efficiency and a seamless user flow. At the core of this layout is the AI toggle, activated by the Ctrl and A keys. For managing workspace views, the teal highlighted keys, including S, D, F, G, and Alt, initiate frame mode. Navigation is primarily handled through the H, J, K, and L cluster, providing intuitive directional control without the need for a mouse. Playback is conveniently mapped to the spacebar and the 8 key for instant pausing and playing. Search functionality is located on the bracket keys, while the theme cycle feature is positioned on the bottom right of the keyboard. These shortcuts are engineered to minimize movement and keep the focus entirely on the content. The future of Rust command line interfaces is centered on transforming the terminal into a sophisticated platform for modern software. By running the command cargo install wipe, you can experience a new standard for terminal multimedia. This project serves as a definitive proof of concept, demonstrating that the terminal remains a viable and powerful operating environment for the next generation of applications.